going to be punctual in this class because otherwise they will be stopped. Okay, so what is the resolution? That's right. We have a vector and its angle, and we have vector and its angle with the horizontal is good. Right. So this is the horizontal part, and this is the vertical part. Right. This is x-axis. This is y-axis. So let's say the vector magnitude is, let's say this is 3, 3, right? And the angle with the horizontal is, okay. So what we can do is that, let us write it generally. So let's say that this is, okay. So we already know that we can write any Cartesian vector in the rectangular form as a vector equals to, in Cartesian form, axi plus ay. Right, yes. So this is the Cartesian form of a vector in a plane. Right, in a plane meaning we have that x and y. Okay. So now what we can do is that we can resolve this vector A in the form of the horizontal part, which is ax, and the vertical part, which is ay. Right. So ax would be, you already have learned that ax would be a cos. And then you have this vertical component or vertical part, which is a sine. Right. So you have learned this before, right? In your Amna ma'am's class. Right? Yes. Sir. Yeah. So you can write ax as a cos theta and ay as a sine. Right. So then you can write the vector as a cos theta I have plus a sine theta. So you see that in the polar form or in this form, you have only the magnitude of A and the angle between the horizontal and the vertical, right? Magnitude and the angle. But in case of this, you have the x component and the y component. So you can write any vector which is given, whose magnitude is given and the angle with the horizontal is. So you can write this vector as this one, right? And let's say that we have an example. Let's say that we have a force which is acting in this way and its magnitude is 20 meters. And the angle is what, let's say 60. Okay. So we can write the vector as in the Cartesian coordinate as this is 20, right? So a cos theta I have and a sin theta. So yeah. So a is how much? 20, right? Cos 60. And I had plus a again 20 and then sin. So what is the value of cos 60? Yasir? Yes. 1 by 2. Yes, absolutely. So be confident, yes. Be confident in your answer. Whether it is wrong or right, the other thing. But be confident. Yeah. So and then sin 60. Sin 60 is how? Sin 60? No. So we have cos 60, which is 1 by 2. Then cos 60 cannot be equal to sin 60, right? If cos 60 is 1 by 2, then this would be different, right? So just remember that this is 2 by 8. Okay. Now we can write this 10 cancel and this 10. So this is 10i plus 10. So you see that this vector was given in the form of this. The magnitude of the vector was given and the angle with the horizontal was given. Right. So then we can write this vector in the form of Cartesian. Cartesian. So this is the idea of the resolution. This say you have got, right? Okay. And always remember that if you're writing cos theta, so cos theta, so that would be only with yours. So if you have the angle so let's say you have an angle which is let's say this is 60, and then this is let's say 10, right? So can you please quickly tell me what would be the Cartesian form of this vector? Just remember that the angle will always be with the horizontal. So this is the horizontal, this is the vertical. This angle would be how? This is the angle that this vector is making with the horizontal. So this angle is how much? Yeah, 30, absolutely. So this angle is 30. So the theta is 30. Right. So you quickly tell me what would be the Cartesian form of this vector. Quickly tell me. And then we will do a question of JEE pass. Yeah. So write your answer in the chat. And what is happening? Yeah. So 10 cos absolutely right. So 10 cos and 10 root 3 by. Yeah. So this is as you say. So 10 cos 30 I hat plus 10 sine 30. So 10 as you say root 3 by. So 5 and 10 1 by 2. So 5. So 5 I hat plus 5j. Good. So this is how we write the resolution of the lecture. Okay. And the second concept that I'm going to use is that. So this was in the 2 dimension. Okay. In 3 dimension, we have x, y, and z. Right. So in 3 dimension, we have x, y, and z, and you have a vector. So you have a vector which is this. Just remember that this vector is not in the plane. Okay. So just try to imagine that these are the 3 edges, right? So you are standing in the corner of a wall. Okay, you are in a room and you are standing at the corner. So this is the floor. This is the floor and this is the height of right. And the vector is diagonal. So diagonal of roof, right? So then if this is the alpha, so this vector is making an angle alpha with horizontal x. right? And then this is making an angle beta with y, and then it is making an angle gamma with z. Okay, so yeah, this is appearing that alpha plus beta is 90, right? But it is not, right? Because you have these x, y, and z coordinates, or right? And then you have a vector like this. So if it is making an angle, let's say this one, so this is making an angle this one alpha with x coordinate, right? X axis. But this is making an angle beta with y axis. So you can see that these are not complementary angles, right? So alpha and beta are not. If you were in a plane and this vector was in this plane, so let's say that you have a plane. Okay, you have a plane, and the vector is in this way, in this way. Vector is not here, right? So vector is in this plane. So if it is making an angle alpha with this horizontal, so this would be 90 minus alpha with the y. But if the vector is not in a plane, so then whatever it is making with this, where the y-axis angle would be different. So is that clear? Yes. Yes, yes, is that clear? Yeah. So did you understand about this alpha and beta not being complement? Yeah. So I see it that let's say that this is XY plane. This screen that you are seeing, right? So if my vector is on this screen only, right? So let's say that you have this plane, right? This plane. So you have x-axis and you have y-axis. Okay, and the vector is in this way. So on the same plane, in the same plane, right? Vector is in the same plane. So whatever it is making with the x-axis, the y angle would be complement in this case, right? When a vector is in this xy plane. But for the three-dimensional case, so you have x-axis, you have vector. Let me bring the three-dimensional object. So you see that this is a three-dimensional object. So it has some base, right? So this is the base, right? And this is some another base, and this is the height. So this, right? So the vector is like you have this base and this height. Is that clear? So for a three-dimensional object, if you are making a vector like this, right? And this vector is not in the xy plane, not in the xy plane. So this alpha and this beta would not be common. This is what I am saying. Is this clear now? Yes. So the vector is like this in the three-dimensional system, right? So this is the alpha angle, and this is the beta angle with the vertical. Understood? Yes, clear. Yes, sir. Okay, so then we have the direction cosine. For the case of a three-dimensional system, we have direction cosine, right? So this is alpha, right? So this is ax, x component, this is y component, and this is z component. Okay, so ax would be simply a cos alpha, ay would be simply a cos theta, and AZ would be simply A cos theta, right? So if I write cos alpha, so this would be AX by A. And if I write cos theta, so this would be AX, AY by A. And if I write cos gamma, so this would be simply AZ by. So these are three cosines. These three cosines are called d-dimensional. Okay, for the three-dimensional system. So did you get this point? Yeah. Yes, yes, did you get this point? So this, I guess, you have already learned in. So then you can write any vector in the three-dimensional coordinate system like right. So this AX would be simply A cos alpha I hat plus AY is A cos theta, right? J hat, and this is A cos gamma. So this is the vector in the three dimension. And you have a result. So cos squared alpha plus cos squared theta and plus cos squared gamma. So this is one. So this is one result. Okay. So this was about the direction question. So for the resolution of vectors, two part is important. One is this two dimension, one for the two dimension, right? For the two dimension, this is the resolution of vectors. And for the three dimension, you have this one. Okay. For the three dimension, you have this one. And you have to remember the direction. So these are the things that you need to know. And you have this dot product also. So dot product or the scalar product. But before we go ahead, let us solve the question based on the resolution of it. So yeah. Okay, so the resultant of these forces is approximate. So this question I gave in the previous class, but nobody. But before we do that, let me let, let us do this question first. Right. We have this one. So how many vectors do we have? We have OP vector, right? OP vector. We have OQ vector, and we have OR vector. We have OS vector, and we have OP vector, right? 1, 2, 3, 4, 5. Yes, you got disconnected. Network issues, yes. Yes. Am I audible? Yes. So we were doing this question based on resolution. You see that we have how many vectors? Right? We have OR five vectors. OP, OQ, OR, OS, OP, and five vectors. And we cannot apply Parallelogram's law or triangles law one at a time, right? To solve all these vectors, we cannot apply parallelogram. So what we can do is that we dissolve each vector in the Cartesian form, right? Then we can easily calculate the resultant of it, right? So this would be the idea for this vector. So first we need to find out the OP vector, OQ vector, OR vector, OS vector, and OT vector, right? And then just find the resultant, which is OP, OQ, OR, and OS, and OT, right? Oh, but I forgot. So did you note down this part? Do you want to note down this part? The direction cosine part. Yeah. Or have you done it already? So, oh, good. Okay, so now let us focus on, yeah, that will see. Okay, so where were we? Need to find out the resolution of OP vector. Where is OP vector? So this is OP vector. This is a 30-degree angle and magnitude is 20 meters, right? But this is with the vertical. With the horizontal, it would be how much? It would be 60 degrees, right? So then we can write OP vector as 20 cos of 60 I hat plus 20 sine of 60 j. So this would be 20 half I hat plus 20 root by 2 by j. So 10 and this is 5. So 5i plus 10 root 4. This is not 5, this is 5. So 10i plus 10 root. So this is rupee vector, right? And then we need to also calculate what is OQ vector. So let us calculate what is OQ. For OQ, for OQ we have this 10 and this is 30. So this is OQ, right. So this would be how much? 10 cos 30 I hat plus 10 sine 30 j, right. So 10 root by 2 I hat plus 10 1 by 2. This is 5, this is 5. So 5 I hat plus 5j. This is okay. Right. Now we need to calculate what? Now we need to calculate OR. So let us calculate what is OR. For OR, where is OR? This is right. So for OR, we have this angle with the horizontal is 45 degrees. So this is OR. This is 45 degree and this is 20. So OR would be how much? 20 cos of 45 and I hat plus 20 sine of 45. And now there is a crucial thing. So what is this direction? This was I. So this is I hat. What is this direction? Yes, Yasir. What is this direction? Is it a J hat or some other direction? Yeah, so you see that J is this one. This is so this is what opposite of J, and you have already learned about the opposite vectors. No, 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 not. So opposite of J vector would be opposite or negative, right? So this would be minus J, right? If this is J, so let's take the example of, so this is x-axis, so in the left you have minus x-axis. If this is the y-axis, so in the bottom you have minus y. So if this is J, so opposite of J would be minus. If this is I, so this would be minus I. We are in the plane, right? So we have only two directions, I and J. Okay. Is this part clear to you? Yes. Yeah, is this clear to you? Yes, why this is minus J? Is this clear to you? Yes. Yes, yes, sir. Clear. Should I go ahead? So if you have any doubt, you can ask. Yes, yes, sir. Yes. Yeah. So understood, Yasir. Yes. So a bit. Okay. So we should completely understand, right? So yeah, you see that we have understood about different type of vectors. So if this is a vector, right? And if I want to write the opposite of a vector, so this would be minus a vector, right? Only the direction is opposite. Magnitude is same, but the direction is opposite. So this is also called a negative vector, right? So if I also want to write a parallel vector of A, so that would be, let's say, right, this is some parallel vector of in the same direction, but it has a different magnitude. So this is how we can write a different vector. So if this is J hat, so the opposite of J hat would be minus J. This is okay. So now let us go ahead. So 20 cos 45. So 21 by root 2 I have. And sine 45 is how much? Yes, yes, sine 45 is how much? Yes, absolutely. So 1 by root 2 So if I multiply with root 2, right? So this would be how much? So this is 10 and this is 10 because we have 2 into 10 and 2 divided by root 2 is so this would be 10 root I minus 10. Okay. So OR we have calculated and then we have what? And then we have OS, right? So OS would be how? This is OS and it is making an angle 45 degree would be horizontal. So can you tell me what would be OS? Please please quickly. Yeah, quickly tell me, Yasin, what would be the best? So just see that this is which direction. Just remember that this is which direction. So this is I. This would be just remember that this would be minus I. This is J, so this would be minus. So you will have 15 cos, this is 45 and minus I, and then 15 sine 45, and then what? Minus. Yeah, yes, absolutely. This is correct. Again, so we'll have what? 15 by 1 by minus I and minus of 15 by. So we will have how much? So we can write this as and y, and this we also can write it as 15 root 2 y. One moment, just. Yeah, sorry about that. Yes. So what is minus 30 by? Yeah, so this is root 2. Okay. Oh, this is I. This is I and this is J. Yeah, so okay. So this would be how much? So this is 7.5, right? So minus of 7.5 I hat and minus of this is 7.5 and J. So this is OS. Now the final, yeah. So minus 15 I by root 2. Yeah, this is also okay. Minus 15 by root 1. But you see that we cannot write a root in the denominator, right? So this is not the convention. The conventional way is that we write root in the numerator. So that is why. No, there is no harm in writing in this way. This is also correct, absolutely correct. But in the conventional way, we write root in the numerator. So that is why. Yeah, so we have calculated OS now. And now one more vector is remaining, right? One which is remaining, which is OT. So you see that OT is with the horizontal, right? So with the vertical. So we will make it with the horizontal and this would be 30. So then we can write OT as 15 cos and 30, and this is yeah, minus I. So 15 cos 30 minus I and 15 sin 30. Yes, yes, yeah, correct. So 15 and cos 30 is root by, right? And minus I plus this is 15 and simply 1 by 2. So this is 7.5. So this would be how much? Minus 7.5 or root I hat plus 7.5 G. So now we have all the vectors. We have all the vectors, and now we can calculate the result. So resultant would be 10I plus 10J plus 5I plus 5J plus 10I minus 10J, and we have a minus of 7.5 I and minus of 7.5 J, and then we have minus of 7.5 I and plus of 7.5. So this is what, right? Then this is what. Okay, so now we have to just simplify. So I, and I, and this is again I, and this is I. So we have 10 plus 10 root plus 5 root I, and plus 10 root 2, and then minus 7.5 root 2, and then we have a minus of 7.5. So this is I, and the rest ones are digit. Okay, so plus of how much? 10 root plus 5 and minus 10 and minus 7.5 root 2 and plus 7 point. So this is okay. So what would be the answer then? So we have 5 root 3, right? So root 3 value is given. Root 3 is 1.7, root 2 is 1.2. So we have to just plug in those values, and let's see what is the answer. So root 3 is 1.7. So 10 plus 8.5, right? And plus 1.4, which is 14, minus 7.5 into 1.4. So, and this is 7. So 0, 5, 10, so 10.5. 10.5, and this is how much? 7.5, 1.7. So 5, 7, 12.7. This is I, right? So let us check if we are getting what. So this is 24 plus 8.5. 24 plus 8.5. So this is 32.5. And minus of how much? So 10.5 and 12.75. So 5 and 3. And this is 13.25. So 32.5 and 13.5. So 5, and this is how much? So this is 4, 2, and this is 9, right? 12, 3, 9. So 9.25, this one. We don't calculate the rest one because we have only this one. So is this clear? Yeah, is this clear to you? Yes, is this clear to you? Do you have any doubt in this question? Yes, Yasir, do you have any doubt in this question? Yasir, can you hear? Yeah. So any doubt in this question? This was just, do you have any doubt? Oh, okay. So this was just the simplification, right? This was just for the practice because you have five vectors and you just simplify. So please note down the question as well as the solution. So please note it down. And whenever you have completed, please tell. Yeah, should I? So whenever you need me to scroll down, yeah, so okay, you just put the screenshot. So all these screenshot that you have taken, complete screenshot, you take the complete screenshot. Yeah, so you will take the complete screenshot of it. Okay, I guess. So what we will do is that we will stop it here because only you are here. So what we will do is that we will stop at this question and I will give you this question as you go. So this is the same question, but in a different way. So yeah, this is the same question, but in a different way. We have, yeah. So please take the screenshot of this question, fourth one. Okay. And this is the question for you. So let me give you a hint. Let me give you a hint that you need to find out the resolution of OA vector, right? This is OA vector, resolution of OB vector, and resolution of OC vector. You find out that, and then you calculate what is OA plus OB minus OC. What is that vector, right? So this will come out in the form of, let's say, AXI plus AYJ. Right, this will come out like this. So the result will have the X component and the Y component. So just remember that whenever you have this X component, right? So this is Y component, this is X component. So then you can calculate the angle by dividing the Y component by X. So this is what you need to do. These are the steps that you need to follow. And one thing is given that magnitude of OA, OB, and OC are equal. So let's say that magnitude of OA, which is equal to OB, which is equal to OC. This is